Assalamu alaikum. I'm Vivian. I will be explaining you the first part of chapter 4, which is about chemical equilibrium. Let's start by the objective. Actually, I will list only the first objective, which is about to distinguish between complete and reversible chemical reaction. The second one we will talk about in the slides. Let's do a small or an introduction to introduce our lesson. You have studied in grade 9 that hemoglobin, which is a molecule found in the red blood cells, carries oxygen in blood. Hemoglobin has the ability to combine with oxygen, but also it has the ability to release this oxygen when necessary. Look how. This is the red blood cell that is at the level of the lung. Here are the oxygen molecules represented by blue balls. Oxygen comes and combines with hemoglobin inside the red blood cell molecules. So as you can see here, this red blood cell carries oxygen bounded with hemoglobin. Now, this blood goes to the tissues or to the cells, and then it releases again the oxygen to the cells because the cell needs it. So as you can see here, oxygen is combined by hemoglobin, and at time it is released by it. So, at the level of the lung, as we said, hemoglobin, that is symbolized by Hb, combines with O2. We can write here an equation. Hemoglobin plus 4O2 will give me HbO8. This is equation 1. At the level of the body cells, the opposite will occur. It means HbO8 releases oxygen to the cell as the following. As you can notice here, that equation 1 and equation 2 are opposite to each other. So, equations 1 and 2 can be written as Hb, that is hemoglobin, plus 4O2, that is oxygen, combined together to give HbO8, and in turn, HbO8 will go in a reverse direction in order to produce again Hb and 4O2. So, as you can see, here is the lungs, and here are the two pink balls which represent oxygen. As you can see, red blood cells comes to lungs, takes oxygen, combines with oxygen, it means, and go to the body cell where it releases in its oxygen, and so on. So, as if this reaction is going to occur in this direction and in this one. So, does a reaction always proceed in the same direction, or can it be reversed? In other words, does a reaction always proceed in the way that reactants will give products, or it's possible then a reaction reverses and go in a direction or in a way for the products to give reactants? Actually, some reactions proceed in two directions. Now, what about complete and reversible reactions? When the reactants in a reaction reacted completely to give the products, the reaction is said to have gone to completion, and it is called complete reaction or irreversible. This is the case, for example, of the hemoglobin when it combines with, this is the case of all chemical reaction you have studied so far. It means from grade 6 maybe you have studied that simply reactants will give us products. But in some reaction, the reactants reacts to form the products in a forward reaction, and the products in turn can change back into reactants. Such reactions are called incomplete reactions or reversible. Actually, this is the case of the combination of hemoglobin with oxygen. This kind of reactions is represented as follows. Here are the reactants. They go in a forward reaction to produce the products, and the products in turn, as we said, react to produce again or to produce again the reactants in the backward reaction. So we use two arrows, as we said, in order to say that this reaction is incomplete or reversible. So when the reactant, here there is a note to pay attention to, that the forward reaction can also be called simply direct reaction, and the backward reaction can be called indirect or indirect. It is the old pronunciation in this word, but so far it's pronounced as direct and indirect reaction. Here, let's do a concept map that summarizes what we have seen so far. So a chemical reaction can be either complete or incomplete. Complete, it means irreversible. So the reactants transformed into product, and as we said, this is the typical case of all chemical reactions so far seen in chemistry. while the incomplete, they are called reversible. They are characterized by that the reactants and the products are present at the same time t. Reversible reaction now. In a reversible reaction, at the beginning, there is only reactant or reactants. The forward reaction takes place at a high rate, while the backward reaction is slow. Look how these are the reactants. In the forward reaction, they give the product, and the product changed back to give what in a backward reaction to give the reactants. But here the arrow is written with a big size to show that this reaction, the forward one, is faster. With time, the rate of the forward reaction decreases. Why? Because the concentration of reactants will decrease. And you know from the previous lesson that the concentration is a kinetic factor. So with time, the reaction rate decreases. What happens now? The products are going to be formed with time. So the concentration of the product will increase gradually. What will happen in this case? The rate of the backward reaction will increase with time because the concentration of the product is going to increase since the reactants are transforming into products. Now, the reaction system, it means the reactants and the products will reach a time where the rate of both forward and backward reactions becomes equal. And at that moment, we say that the system reaches an equilibrium state. So the reactants will give the product in a forward reaction and the product will give the backward reaction, but at equal rates. Now, what is chemical equilibrium by definition? Chemical equilibrium is the state of a reversible reaction where the rate of the forward reaction equals the rate of the reverse reaction. At equilibrium, the reactants and the products are still present at time. The chemical equilibrium is said to be dynamic. What does the word dynamic mean? It is dynamic since although at equilibrium, the reaction seems to be stopped, in reality, there is no stop. Both reactions, forward and backward, are occurring at equal rates. Let's consider this example, the simulation, to understand how. Look at this man. He is running on a treadmill. Now, this man appears to stay in its place. But is he motionless? No, actually it's running. But why it stays in his place? Because look at the treadmill. The man is running in the forward direction and the treadmill is going to move in the backward direction. And the man has the same speed as that of the treadmill. This is why it stays here. So you can imagine that this man corresponds to the reactant of a reaction, and this treadmill corresponds to the products. So the reactants are going to transform into product in a forward reaction, and the product are going to transform into reactants in the backward reaction, but at the same rate. So we will reach what did we call the state of equilibrium. Here is another example to understand how equilibrium is occurring. As you can see, this ant took a part of the reactants and it will carry them to the product, and in turn this ant did the same. But look at the reactants and the products and forget what the ants are going to do. Actually, for us as observers, we said that nothing is changing because the quantity of reactants and that of the product is the same. But in reality, no, there is a change, but since both ants are working at the same rate, this will not lead to any change at the level of the quantities of reactants and the product. So this is another example for equilibrium. Finally, a third example, you can also imagine the quantity of liquid found in both cups. Here, look, we are using 3 straws. Now we are taking, for example, 2 drops from here to pour them here and 1 drop from here to put it here. So we can continue this operation from now till I don't know which time. But look at the level of the quantities, it means of the ink here or of the colored water, nothing will change. They are in equilibrium that is dynamic. So I will ask you now to read with me the summary. So the definition, as we said, the chemical equilibrium is the state of irreversible reaction where the rate of the forward reaction equals the rate of the reverse reaction, and it's represented in that way. And at equilibrium, the reactants and the products are still present. Thank you for watching. Do a pause to read what is required from you in the agenda, and I will see you